Hello, calculus scholars. Now in this video, I'm going to kind of show you specifically type 1 definite integrals with substitution. Now these exercises actually are more conceptual than the type 2. So they are going to appear a little bit more abstract. I'm actually going to give you fewer of them. But what is nice about these exercises is they're going to really give you some good understanding of U-substitution in general, and really build you to a good conceptual understanding. So what we have here is we have a function. It's kind of in terms of x in function notation, and our goal is to get it in terms of u. So it says, let the function equal to 9. So write an equation that can be inferred involving the integral of the function f of u. So that's what it's kind of asking here at this point. So let's kind of get started here. So first thing that you want to do on example 1 is you want to identify your u. And your du. So our u is equal to 1/3 x squared plus 2. And then our du is going to be 2/3 x dx. And notice here, I have the x dx kind of on the outside, so I can use that, and I can actually get this into a du. But what I do want to kind of do here is get that x dx by itself. So I want to kind of get that 2/3 on the other side. So the opposite of multiplying by 2/3 is multiplying by 3/2. That's what I'm going to do. And so I have 3/2 du is equal to x dx. And I'm just going to kind of box that in green. All right, part 2. Part 2 is to kind of deal with those limits of integration. So we must kind of address that at this point. So my limits of integration, I'm going to say that u of -6 is just plugging in your -6 into the u function. This is the limits of integration part. So I'm going to do 1/3 times -6 squared plus 2. That's going to be 1/3 of 36 plus 2. That gets us to 14. And then I'm going to do use of 3. So that's going to be 1/3 times 3 squared plus 2. That's 1/3 of 9. That's going to be 5. And then for part 3, I write the integral in terms of u. All right, so what we're going to kind of do here, I like to actually just write this a little bit out of order at the beginning. So I'm going to write this as a -6 to 3 of f of 1/3 x squared plus 2 times x dx. And you'll see why I do this here in a minute. And that equals to -9. And what we're actually going to want to actually do is come up with an equation that can be inferred. So we're actually going to change this into kind of a U type of integral situation. So what I'm going to kind of first do here is address the situation. So I'm going to change my limits of integration. Now, I must get it in order here. So the -6 becomes 14. And the 3 becomes 5. And instead of this 1/3 x squared gibberish, I'm going to actually just call this U. And then this x dx, and I'm just going to go back into green for this part, because this was kind of like dealing with the du. So I'm just going to say that that is du. 3/2 du, to be exact, is equal to -9. All right. So now what we want to do, notice here that I have this constant of 3/2. So I'm actually just going to take out the 3/2 and put it in front. And I'm going to stick a negative sign in front as well. And I'm going to flip that limit of integration so that it goes from 5 to 14. I always like having the smaller number on top or on bottom and the bigger number on top. So it is very important to flip it. And that's why I have that negative sign. And then I'm going to have an f of u du equals to -9. And then what I'm going to do after that is I am just going to multiply -3/2. I want to get rid of that fraction. So I'm going to get it so that it is flipped. So I'm just going to multiply both sides by -2/3. And we can see that there's some nice cancellation that's going on. So -9 times -2/3 equals to 6. So I'm going to say then that the integral of 5 to 14 of f of u du is equal to 6. And that is as far as we can go. So let's actually try this out right now. So my A is going to be 5. My B is going to be 14. And my function, that integral, is actually going to be equal to 6. And then we are good. I always recommend when you have these conceptual questions as well, if you're kind of working on these independently, I really think it is important to kind of look at the solutions. You can kind of see a little differently how Delta Math does it. They actually kind of do the work on the bound of the integral. So you can kind of see the steps that they laid out. I really wanted to kind of go through each step and kind of tell you why, we were doing each part. So if you just kind of, to reiterate, think about limits of integration, and then think about getting that integral in terms of u, then you're good. And then your goal is to actually just get the integral from 5 to 14 all by itself. You can kind of just circle that that's what you want to get by itself. All right. This one says write a integral that is equivalent to this integral -2 to 1 x times the f of 3x squared minus 2 dx. So first thing that I would immediately do is work out your u and your du. So this is example 2 now. So my u is always going to be in the parentheses. So I got 3x squared minus 2. My du is going to be 6x dx. And if I want to just notice, I got x dx on the outside. So I'm actually just going to divide by 6, or you could also just say that you are multiplying by 1/6. I like to kind of do that, because that way you don't have a fraction below a fraction. So that's something that's always helpful. So then after that, you get that canceling that's going on. 6 times 1/6 nicely cancels things out. So I have that du, 1/6 du is equal to x dx. The second thing that I want to do is the limits of integration. So I'm going to do u of -2. So that's going to be 3 times -2 squared minus 2. It's 3 times 4 minus 2. So that's 12 minus 2, which is 10. And then I'm going to do u of 1. So that's 3 times 1 minus 2. So that is going to be equal to 3 minus 2, which is just 1. And then I want to actually write this in terms of u. So what I would actually do for this one, you don't have to do this step, but I like to, just write the original integral a little bit out of order. So I'm going to do the f of 3x squared minus 2 x dx. And the reason why I like to do that is just so you can kind of see how that x dx becomes the 1/6 du. So when I do that, I'm going to write my new bounds. So this is going to be the integral from 10 to 1 of f of u. And then this x dx becomes 1/6 du. And I'm going to just flip the integral. So I'm going to put a -1/6 instead of a +1/6, so I can get that integral nice and flipped. So it's from 1 to 10 of f of u du. And now I have kind of a nice working integral. So my lower limit of integration is 1 to 10. And my coefficient is going to be -1/6. And we are good. Now, if you kind of notice here on the delta math, they actually put the bottom limit as the bigger number, but I think it's always good to get in the habit of making sure that your bottom limit is actually the lower of the two numbers. All right, the third type of problem. This gives you the idea here. So it says if g prime of x is equal to f of x, with g of -1 equals a, g of 0 equals b, g of 3 equals c, and g of 4 equals d, express the value in terms of a, b, c, and or d. All right. So what this is saying here is that g is the integral or the antiderivative of f of x. And they just kind of do that notationally speaking. So note, this means that g of x is the antiderivative of f of x. All right. So this will start very similar to the way that we did the other problems. So first part, u du type of stuff. So our u is equal to 1, and this is example 3, by the way. This is going to be 1/3 x squared. Our du is going to be 2/3 x dx. And I want this x dx to be by itself. So I'm going to multiply both sides by 3/2. So I'm going to get that 3/2 du is equal to x dx. And then 2. Limits of integration. So for this, I'm going to write u of -3 first. So that's going to be 1/3 times -3 squared. So that's 1/3 of 9, which is 3. And then u of 0 is 1/3 of 0. And then I'm going to write this as an integral in terms of u. All right, so for what we would do here, I'm actually just going to do the step where I'm not really changing the order, or I'm changing the order first, but not changing it into u yet, just so people can see where our initial U setup is coming from. So we got a 1/3 x squared x dx. So this x dx becomes 3/2 du. And then this becomes your f of u. And we're going to go from, for our new limits of integration, we're going to go from 3, by the way, this limit of integration here is 0. And then I'm just going to pull out that 3/2 and flip the integral sign. This is going to be a negative 3/2. And then we're going from 0 to 3 of f of u du. Now note, g of x is the antiderivative of f of x. So what this means is if I'm taking the antiderivative, I'm going to take this negative 3/2, and I'm just going to multiply it by the antiderivative of f of u, which is called g of u. And our limit is from 3 to 0. So it's going to be a negative 3/2 times g of 3 minus g of 0. So that's going to be negative 3/2 times c minus, and then g of 0 is b. And this is an expression in terms of a, b, c, or d, and or. So I'm just going to put that in. So I got negative 3/2 times c minus b. We'll submit the answer, and we are good. So that one is a little bit conceptual in the sense that you have to connect that. It says if the derivative of g is what is inside what you need to take the antiderivative of, then g itself is the antiderivative. So once when you get past that, it actually is a pretty nice setup with minimal algebra needed. And I always like to just kind of get in the habit, a little different than delta math, of getting that bottom limit on the bottom, top limit on the top. What they actually have here is logically equivalent, believe it or not. So we are good.